I feel like the only time I can compare with is actually when human got language. That's the only time that's comparable with now.
What if we're witnessing the most important moment in human history since we first learned to speak?
There's no fundamental barrier. There's no some reserved place for human. I don't think there is such fundamental difference. The border of your language is the border of your world. Based on that, we can build more and more layers on it, and there's no limit.
Stanford professor Xiaoliang Qi discovered something that changed everything he thought he knew about intelligence, creativity, and what makes us human.
I think each of us, we feel like we have to do something at this moment. So I think startup is a more direct way that I can turn these ideas into reality. It really feels like two full-time jobs. I've been working day and night. I also spend a lot of time learning to code and learn all these things starting from scratch.
He took on the impossible challenge of running both worlds simultaneously and risked everything on a vision most people thought was impossible.
What we are going to see is the next 10 years, maybe we are going to see more change, more dramatic changes than the past 300 years. It's going to enable all the students to work like professors, reduce the barriers everyone in the world could access that.
What he's building isn't just changing science, it's rewriting the rules of human potential itself. What if we're living through the most significant moment in human history since the invention of language itself? Professor Xiaoliang Qi, a Stanford physicist and AI entrepreneur, believes we are, and he's betting his career on it. While continuing his prestigious role as a Stanford professor, Qi co-founded Path Integral Technology, building TXYZ.ai, an AI research platform that's transforming how researchers discover knowledge. But this isn't just another tech startup story. Qi is one of the world's most cited quantum physicists, with over 84,000 citations for his groundbreaking work on quantum entanglement and gravity research that's literally reshaping our understanding of reality itself. In this mind-bending conversation, Professor Qi reveals why he believes AI isn't just copying human intelligence, it's about to surpass it in ways that will make the next 10 years more transformative than the past 300. We explore his radical thesis that language is the ultimate technology, why AI scientists may soon make discoveries no human could imagine, and how his company is building the infrastructure for a new kind of civilization where humans and AI collaborate as equals. This isn't just about better tools, it's about the fundamental evolution of intelligence itself. Let us get started. In fact, there's a whole theme that is happening now, AI for science. And in fact, this year, the Nobel Prizes, there's so many AI scientists getting Nobel Prizes. For example, using the AIs to solving the protein docking, the prediction of molecule. And so I'm very curious about your thoughts about AI for science. How do you think about this current trend using AI for science? I think right now we're still primarily using GPU for that purposes. What is the current status? What is the future for AI for science?
Yeah, so I'm certainly very interested in this direction. That's part of the reason I started to work in this field by starting this startup. I think there are two kinds of directions that in AI in science. One is like the protein folding. Right? So these are the developing new machine learning methods for a particular task. Say I define this task of protein folding, and then you can design a model particularly for that, and with the current new technologies, new algorithm and computational power, you can get wonderful results. And then the other direction is the general aspect, which is related to the language model, which means AI scientists, which means that in addition to these specialized tools, there are also all the works of scientists, which means come up with new ideas, understanding other people's work and then come up with new ideas, and then plan a work and really do the work and use all the existing tools correctly, and then invent new tools if needed. So all these kind of aspects are not specialized to a particular task, but it's like the connection that connect all the specialized things together, and that's the role.
It's the intelligence.
That's like the role of human, and this also with the current language models, this can gradually be not completely replaced, but like by can be taken care of by AI. And that part, I think, in longer term, it may even lead to a bigger dramatic effect in the AI for science.
You touched a very fascinating point about about letting AI to take the process of knowledge discovery itself, because we used to think that we human beings is the only species in the planet that can discover new knowledge. Because we have this logic, we can reason, we can understand the observation we had, and then we can come up with science. That's basically the jewelry of our human civilizations. And now what I hear you say is that, like, you believe there's also a possibility that AI can do science as well. So they can, and the scientific process by inherently is a process, is a systematic way to seek knowledge, which you need to collect the data, you need to run the experiment, figuring out which hypothesis is right or not, and moving forward. And it is possible for AI to automate the whole process. Is that accurate?
Yeah, so that's what I believe. Yeah, I think that's also why I like 2 years ago I co-founded this path integral technology, where we want to work on language model applications in scientific research, because my motivation was, I think there's no fundamental barrier. There's no some reserved place for human. Like we can like some people think AI is just copying what we're saying, like interpolating between known things, but we can be creative. I don't think there is such fundamental difference. I think I have this point of view because I study quantum information and space-time. So I would like to view everything from the information point of view. And when you think from the information point of view, there is no fundamental difference between me watching, like looking at a message on my phone and then forward it and then add some more message. I'm just processing that information. And the AI with a powerful enough AI model can certainly do the same kind of information processing. So the language model really opened up this possibility because it processes language, and everything we can communicate with each other is language. So there is no limit. Like I can describe any task, like driving on some road. All right, I can also describe in language, right? Like navigation, right?
Yeah.
I can describe like playing chess. Let's say if you have a model that only plays chess, then you can't do other things. But if I have a language model, it can play chess, right? Because we can just describe, oh, I want to put this here, and I want to put that on that coordinate. We can just chat, and then we're playing chess.
Yeah.
And you see this video that DeepSeek and ChatGPT play chess. so that's why language is universal, right? So once the AI has the capability of using language, processing the information in the language, then in principle it could do anything we can do. So I think in the end, it's going to do anything we can do.
We are basically information processor. We use language to communicate information, to process information. And if we are just information processor of languages, and if we can have a language model, and as it evolves, it can do as good as we do, or even better.
I think the key, like when we think about information, what are we thinking about? Like if we make a phone call, and then when I talk about the information I send it to you, that means I don't care about the physical content, right? I don't care if this message was sent to you through the electromagnetic wave or by sound wave, like we are communicating in person. So the format doesn't matter. It's the information content that matters. So when we think it that way, then really the AI can process any information that we can process. I mean, of course, when we talk about language, it may be like what I mean is a little general sense, because like we also want AI to be multimodal. It could process video and audio, right? It could also understand.
So language is basically like a symbolic representation of information.
Yeah.
And because this is such an interesting topic, so I want to dive a little bit deeper into that about the language and intelligence. Because, like you mentioned, that anything that we can turn into language, there's no reason why the AI cannot learn it or machine cannot learn it. I'm also curious your thought because many people hold the feeling that there's some part of our intelligence that we just cannot describe in language. Um, some people argue like the art is like that. Of course, like again and again, we prove that something that cannot be described, like art, now can be described. But people believe that there's some inherent, like some core part of our intelligence cannot be described by language or any symbolic system. I'm curious your take on that.
I think, yeah, so this is the quotes from Wittgenstein that I really like, which says that the bound, I don't remember the exact quote, but the border of your language is the border of your world. And so it's like, it's like, yeah, there are many things like arts. There are more and more subtle things that you can't directly describe, but then you try to describe it by, say, you can describe some concept by giving many examples or taking limits of things. So we have things that we can't describe, but we can describe indirectly. It's like it's just like, no, but none of us can really feel the 4-dimensional space, right? We only know 3-dimensional space. We don't have a sense for what is a 4-dimensional space. But in using all the mathematical tools, using the physics tools, we can understand 4 or 5 or any higher dimensional space. And then if I work on that for a long enough time, I can get intuition, just like our 3-dimensional space. Right? I can kind of navigate in that and work on it, although I don't have a direct sense. So that's the magic for language, that it is maybe the daily life, like maybe the starting point, like the building blocks are what we learn in our real world. So they are limited, but based on that, we can build more and more layers on it, and there is no limit. And I think this is related to the Turing completeness. It's like something is Turing complete and you can describe anything with it. And that's my rough understanding to this computer science concept. Yeah.
You mentioned a very great point. It's about what is a language. Like you can either directly refer a thing or describe a thing, which is like explicit description or analytic solutions, or you can just describe have some indirect description. Oh, this is good, that is bad. And it actually reminds me the different paradigm in conditioning the large language model. So some people use prompts. So the prompt will be, oh, please do this. So that is like an explicit description of the instruction. But there's only a subset of things that we can describe or the model can follow. Another way to do it is provide some examples, like training example. Like you have something happening, this is good, that is bad, this is good. And if you think about this whole thing connectively, that's a language, that's a symbolic system you're describing. Although it is not as concise as the previous one, it is a way to describe, and the AI can learn that.
Just another example is what I learned from some other AI researchers, is that when we ask the AI to do certain physics tasks, you just switch from Markdown to LaTeX, makes the answer quality much higher, just because there's more higher quality things happening in LaTeX. But but that's just like human. Like there was all these subtle things in the context of the like what language is being used, what code is being used. All these things, they are part of the information you give the model. And it's not just the explicitly written instructions, but all the subtle part also becomes part of the instruction. So in that sense, like all the subtle aspects of human culture, like arts and all these things, can also be included in the language model, I think.
Yeah, that's a fantastic view. It also like extend our definition what is language, and in fact, many people they think that large language model is a misnomer. It should be a large symbolic models.
It's like a general information processor, which basically means any intelligence.
Yeah, exactly.
So that's why I got so excited in 2023. I feel like what should I compare? Like after I used ChatGPT for a few weeks, and then I feel like, okay, what should I compare this moment with in the history? Like people talk about these, like people talk about iPhone or talk about like industry revolution. But I feel like the only time I can compare with is actually when human got language. Right? Like I don't know when that happens. It could be 100,000 years ago, or could be 10,000 years ago. Sometime between that, we don't know. But there was a time where human language just emerged. Like we just start speaking, and that's the only time that's comparable with now, because what happened is the information processor changed. Before that, the information processor is DNA. It's just we evolve by evolving the DNA. The DNA changes from generation to generation. That's the only meaningful, like relevant change happening in this in the ecosystem. But then after you have language, it's possible to have dramatic changes just caused by words. Right, just caused by I invent something, I tell 100 other people, and so on. Right, so all these things can happen in a scale much faster, in a time much faster than DNA. So the whole world is dramatically changed. So now it's similar, right? So once the information processor is different, and the language is also different, because the AI learned to unify all these things, right? Put all these different formats into vectors, and then it's kind of inventing a new language. So that could mean that the information dynamics of the whole world is like just goes to a new edge where it's so fast. It's just so much faster than before.
Yeah, you mentioned such a fascinating framework to understand where we are for this wave of AI innovations. Because this question, like I think Next Friedman just asked Sundar Pichai on this. So I'm actually comparing our answers to Sundar Pichai. I think our answer is more interesting than Sundar Pichai's. Yeah. What I hear you mention about is actually you are comparing this to the beginning of human civilizations, which is
the
like
language.
The language is really the language marks the human civilizations. And you mentioned about interesting points about is that where the information or intelligence was stored. Like there's several moments that is very important. Like when we have DNA, we have genes. That's the very beginning where we as a species started to store some information, can adapt environment, but that's not fast enough. And then we have our neural system. Then each individual person started to be able to adapt to the environment around them individually. That has been hundreds of millions of years already. Until the very recent moment, probably like 100,000 years ago, something like that, somehow language is invented. And because language is invented, we can directly transfer the experience from one person's mind to another person's mind without the two has to experience the same thing.
Yes.
That really kicks off the civilizations. And that's the beauty of the language and the beauty of us as a society together, because we don't have to learn the thing by directly experiencing.
Yeah, and if we compare with animal language, right? Animal also have some languages, but maybe for kind of built-in purpose. Right? It's like the bees know how to send signals to each other, but that's restricted to the predefined things. So when we say the emergence of human language, more precisely, it's like an emergence of a universal language, which can describe basically anything.
Exactly, yeah.
And then we gradually make it even more and more universal, more precise by inventing science and so on. So it's the emergence of universal language. That was the critical point. And then now it's like the point where the universal language can be processed by some
machines. Yeah, you actually mentioned such an interesting point is that the language, what matters is a universal language. If each individual has their own code, it doesn't matter, because the matter is collaboration. The language made collaboration possible, and it matters now for the intelligence as well, because previously, although we can build computers, very powerful computers, they are not collaborating each other. They are collaborating with a human. They are not like collaborating with each other independently. So they are just tools. They just like under the command and control of humans. But with the languages, I think there will be a moment of this machine starting to have their own civilization, coordinating with each other. I think we now call it agent, but there may be a better name in the future.
Yes, that's exactly. I think that's the key difference. Yeah, when we say tools, right? Like Google is a tool. Because I go ask Google it's a really complicated tool because it requires a huge amount of computation to make it such a good search engine. But you go ask it, and then it give you the list of websites relevant. So, but if you think about the output, it's a limited, it's a very restricted format of output, because whatever I ask it, the output is the sorted list.
Behave the same.
The output is the sorted list.
Exactly.
So that means that I cannot ask 100 Google to collaborate with each other because like the search engine, the search engine give you a result, that result cannot be used to send to another tool. So that's exactly the point you were saying. Like now we have these general models which can communicate with language, then what leads to most dramatic advance is not the capability of a single model. It's the capability that these models could collaborate together and collaborate with human. And then this scaling law is the most important thing. It's like when you consider just putting a problem there and then a team of models and human collaborate on it. And if the complexity of the problem that you can solve by this team grows with the size of the team, then you are done. Even if each team is not very smart, you can like scale it up. And so what in the end, what matters is not the capability of a single model, is this capability of scaling up the complexity of the problem you solve by the size of the team.
So what you mentioned about it, there's like 2 levels of scaling. Well, I will go back to the metaphor we talk about a human. So as a single individuals, our brain just evolves from like 6 million years ago until it's keep evolving until we are Homo sapiens, like 200 years ago. And then it plateaued. It never getting better. So like our brain structure is not significantly better than a Homo sapien.
Yeah, 200,000 years ago or something.
1,000 years ago, like that. We are also talking about the plateau of scaling of individual model. I think there's a metaphor, like parallel between the two. But 1,000 years ago, that was really just the beginning of human civilizations. Like we have, as a society, made so much more progress, not because individual of us become more smarter, but because we form a society.
Yes.
We collaborate. And so what you say is that this is also what happened to AI, because these models right now, we're trying to scale in individual of them, and we feel it's more and more efficient to scale them by taking more power, but they can form a society themselves, collectively gather information, develop their own civilization, and then they can continue scale as a society.
Yeah, I think it's not actually a plateau. Like for the same way as like human brain, it probably will continue evolve, but it's just relatively looks like a plateau because it's so slow compared with the evolution of the society.
Right.
So like the model, probably individual model can also continue improving, and it is. I mean, there is the computational scaling law, and then now there is the test time scaling law, which means like you put in longer context and then you allow the model to think, and there is the scaling law, but this is also individual model. And then once this reach certain level, maybe we are there or we are like close to be there. Once it reach certain level, then we start this much faster scaling law, which is like you form this society, this or the other name we call it is the human AI collaborative network. And then that once you started that, then it's just I expect that will be an easier way to achieve many complex tasks by this kind of collaboration, because human has a lot of experience with this kind of collaboration. So all these things can transfer to the AI. I think that's the other aspect I want to emphasize, which is this kind of transfer of human knowledge, but more important than knowledge is the know-how.
Yeah.
Like because knowledge is like what we read down, like in the papers or in Wikipedia, all these things. That maybe we can just dump to the AI and then train, and then the AI remembers them. So knowledge is something like more static, like it's there, and then if you ask me, I know how to find it. That's it. But the know-how, right, is like how to climb a mountain, right? Like how to ski in an expert way. And then even if I've asked the I ask Xiaoliang Qi to write an instruction on how to ski. It doesn't help me because I can't really
exactly
learn it, right? So
yeah.
so these kind of things are like, I think a lot of the essential parts of why like human society is intelligent, but they were not ready to be transferred until now. Like you couldn't just dump these data to train AI. But this is exactly the thing that now when the model reach certain level, and if they could take instructions better, we start to transfer these kind of know-how to the AI. I think that's the next big thing that's going to lead to a dramatically change. And that's why we're working on this direction of AI scientists, because we feel like the essential thing is we need to get the know-how of human in all these different expertise fields.
There's a deeper level of collaboration between human and AI because of this new paradigm that we're experiencing now.
Yeah.
This is such a fascinating conversation. I think I continue conversation for a couple more hours.
Yeah.
But I do want to dive deeper into your startup journey on this. You mentioned about in 2023, you started your company Path Integral. And for a Stanford professor starting to do a startup, there must be a deep passion for you to choose to do that. Can you tell us a little bit more experience, like your stories, how you get this company started?
Yeah, so the main motivation for me was, as I have said, I feel like this is such a dramatic change. This is like something you can compare with human language. So I think each of us, we feel like we have to do something at this moment, because I think that what we are going to see is the next 10 years, maybe we are going to see more change, more dramatic changes than the past 300 years. Right? So if that's the expectation, then we have to do something. So and then for me, I think a startup is a way that allows me to, because I wasn't a AI researcher that already have an AI research team. I feel like instead of like doing the more fundamental AI research, I want to directly relate these ideas about like, oh, we need to transfer human know-how to AI, and then this collaboration network of AI and human is going to lead to a dramatic new way. It's like a paradigm change for everything, especially for scientific research. So I think a startup is a more direct way that I can turn these ideas into reality. And also I was fortunate that at that time several other friends also is thinking about this, so we kind of just start this together immediately, because we all really want to work on this project.
Yeah, so you basically had this like visions I had about AI and human collaborations, and you wanted to really not just think about it, but actually build real application and real impact in the world. So that's really you started your startup. I'm very curious because as a professor doing the startup, and your vision is also more in broad levels about improving the human AI collaborations. I'm curious how do they approach this when you do the startup? Because you have to also figure out more about the market signals, what exactly the business model it is. Can you tell us a little bit more about your product?
Yeah, so if we think about scientific research or pretty much everything else, like if you are working on something, then there is three parts. The first part is you learn the necessary information, like knowledge. Like I need to get prepared. So if I'm going to do some research, I will first learn what other people have done, and get the essential skills. And then the second part is the main thing, that I need to make my own invention, make my own new thing. And then the third part is I need to send it out and let other people know. I need to write it in a format that other people can understand. And maybe I will go around and give talks. So this is the workflow of scientific research. But if you think about everything else, pretty much there is these three parts: input, creation, and output. So like if I'm making a product, then I also like maybe I do some investigations, and then I have a design, and then I start convert the ideas into actual code, and then in the end the output is a product. So this kind of process is general, and then if I think in that way, then what we want the AI to do is to be there for the whole procedure and become a collaborator in the end-to-end scientific research, including the input and the knowledge creation and the output. So to convert that into a more precise product format, what we did was we first have this product called txyz.ai, which is taking care of the input and output part, which means assistant to help you reading papers, search in the literature, make sure the AI is answering your questions based on facts rather than its own hallucination, and then like a writing tool helping researchers writing papers. We started with that part because that's like a more general aspect, like everyone needs pretty much similar tools. And then after that, now since the end of last year, we have been focusing on the middle part, which is the knowledge creation. And then we're developing a new suite of products that's focusing on letting the AI basically progress from an assistant to a collaborator to do the knowledge creation part of the research. So this is really different from the other two parts because this part requires specialized tools and specialized knowledge in each field. So it couldn't be like one product fits everyone. It will be like me doing condensed matter physics is different from someone else doing quantum computing research, someone doing biology research. Everyone needs an AI collaborator that's access different tools, and it also needs different benchmarks to tell the AI how to make progress. So instead of just having one product here, we need to have a platform which allows researchers in every field to contribute their know-how into format that AI could access. It's like it's like giving AI the glove, right, to access all your experimental equipment and all your computational tools and everything. And we don't do that because that needs expertise in every field. We provide the platform for people to do that. And this is the thing we're currently working on. Like we provide the platform for people in every field to provide the tools and provide the benchmark, and then we build this brain part, like the general AI agent that's capable for doing research. And then you connect the brain to these tools, and then that's the AI scientist in each field.
So what I hear you say, you have two phases of the company. The very first phase, you rolled out a product which is more like an assistant to help the researchers do their job, like doing research, summarize the research, and get an output. So it's more like helping the existing researchers to do research more efficiently. That's phase one. And now you also move to the phase two, which is really building the AI scientist, which is like you build a platform, you build this platform that has this central agentic planner that coordinate on all the tools that we use, and also a platform for each researchers from each individual field to provide the tools they have, maybe this kind of database or maybe the experiment platform they have. And these two combined together will lead to an autonomous system, autonomous AI that will do the scientific discovery.
Yes. So it's a platform where we provide the brain, and then the community provide all the tools to let the AI access the real world. And then this, so it's an open platform that it can keep growing, it can keep being updated with the progress of the research. And we hope this. So we feel like it's the key thing is like there are many people talking about building AI scientists now, and they mostly refer to particular applications like in biology or chemistry, and
we want to
build the AI scientist platform with the entire global scientific community.
Yeah, you mentioned a great point. There's a lot of AI scientists like DeepMind they're building, which is basically AI biologists. They just like specialize on that. But you want to build a platform. It's like a genetic workflow platform, like there's some platform like this, like DeFi, something like that. Allow people to create workflow or create a system. Then that will be applicable for multiple fields. So that's a fascinating idea. I'm very curious that as you have been doing this now in the startup world, uh, what is the biggest challenge that you're facing uh, as you are executing your vision?
I think it's it's how to turn the idea into execution atoms, and has a rapid iteration.
Like the speed, the velocity.
Which is similar to doing scientific research. It's like it's like you are doing something that nobody has done before, and so I mean that's a nice thing for doing a startup in this kind of field. Right? Maybe in a traditional field it's different. So in the AI, it's developing so quickly. So the important thing is not like just find what's the right direction and go for a long time, because nobody knows exactly where to go. It's like we are navigating in a new direction. So it's really important to fast iterate, like try something and then understand the response and understand what the researchers need, and then quickly integrate that into the product, have this faster iteration. I think that's a really key thing.
Yeah, exactly. Yeah. I think you mentioned about a very great point, which is like the difference between the startup environment and the fundamental research in the university. It's like a little bit different, like time scale. Like fundamental research in the university, the time span is like years or even decades on that. But in the startup, it's totally different because it needs to like connect, it needs to reach the product market fit as soon as possible. So the iteration needs to be extremely fast from that. I'm also curious that's related to next topic I have, like, because you are both doing the research at Stanford now, also working on this startup. And they also have a very different philosophies about like the time span as we chat about. How do you balance your professor life versus startup life, founder life?
I think it really feels like two full-time jobs. So yeah, so it's like really I've been working day and night. So I I f- and in the startup side, I also feel like I learned a lot. Um, it's really also in nowadays with the help of AI, with all these tools, it's much easier to learn a new thing. So I also spend a lot of time like learning to code and learn all these things starting from scratch. So I feel like that's really brings a lot of excitement to me, although it also spends a lot of time. Yeah, so other than spending a lot of time, I don't have much like other smart comments about how to divide my time. Yeah, but I expect in longer time, in maybe another 1 or 2 years, when the AI scientists progress into all different fields, then there could be more interaction. There could be
So
like
you ask the AI scientist to take part of your Stanford professor job, and now you can fully focus on startup founder life.
I think they could because that's the motivation is to do scientific research. So I certainly want like the research to be done also in my own field, in like the research in quantum gravity, quantum information. It's not the first field we try because it's kind of very hard to find many well-defined questions there. But I think eventually it is going to go there. Like we already collaborate with other physicists in that field to build benchmarks. So within
I totally see
a few
that,
years, we will see AI start to do more creative works, and then the research, including my own research, will be in a different kind of paradigm, which means that like a team involving AI agents and human. It's not just doing things faster than what we have now. It could mean a different kind of scale, because the size of group, like in our field like mine, the size of group team is not just limited by funding. Like even if you have enough funding, you don't have enough time to collaborate with other people, because the communication overhead is very high. So with AI, it could all change. I think if we look at the comparison with industry, where you have a lot of experience, if you compare how researchers collaborate versus how like people collaborate on an open source project, it's quite different, because open source project, you can have thousands of people contributing, and this project constantly being evolving. And then us, like we write a paper and then we don't have a way to make the paper evolve. Like the paper is just sitting there and then we work on another paper. Right. So the paper is like a outdated format of information. Like it doesn't, it couldn't evolve, and it couldn't take contributions from other people. And it's not alive, but the open source project is alive. So I think it's with the AI communication with human, this could change fundamentally.
Yeah, like maybe there's a live version of the paper. The paper sync themselves, the paper augment and grows.
Yeah, and the paper itself is the agent. The agent is the paper.
Yeah, it's like the, you mentioned such a interesting, and I also find it's very personally funny to me, because I'm building like AI partner for founders, and you are building AI research partner for professors.
I see.
So we work together. We can now go to the beach and don't need
oh yeah,
don't need to do the research and stuff. So like a good answer, like short answers for that question. But to your point, it's not about replacing the job, or whether like the job of professor or founder. It's actually putting the human into the next level. Because if you have your tools where your paper is just like that, it's frozen, then human need to do a lot of work, like on top of it. It's actually a lot of administrative, repetitive work that human need to do. That it doesn't like prevent us from thinking the more high level. But if we have a research partner, or we have a startup founder partner that can help take over all those low-level tasks and really be our partner, even give us new thoughts and fresh ideas, then now we can have the things that is do the things that human really enjoy, is the creative part.
Yeah, totally agree. Yeah, so I always get this question when I give the talks about this, and people say like, "Are you going to replace students?" And then and my answer is that it's going to enable all the students to work like professors.
Exactly.
Right? Because you can delegate the routine works to the AI. So so that's exactly the vision. Yeah.
Exactly. Yeah, like make every student, everyone who want to do research can do the research.
Yes.
With the help of the research partner.
Yeah, and reduce the barriers, like you have to go to these prestigious universities in order to access all the resource and do research there. And so these kind of barriers will.
You put it in a great way, like because now everyone thinks research is such a privileged position, but the inherently is just like for you to have the curiosity, to find out the knowledge, to seek the truth and seek the knowledge of the world. And everyone should have that curiosity.
Yeah, especially in fundamental research fields like mine. Like the most, why is Stanford such a prestigious place? It's mostly not because the material resource provided to everyone here. It's because you have these outstanding people here. You can interact with your colleagues and just chat in the hallway and then get inspired about new ideas. And that's really only like the most valuable part of these kind of top universities, and that could happen for everyone if we have these AI agents that can help explain researches, and then that can help like doing the research, right? So like because my research can be itself an agent, and this agent could be like representing me and explaining to anyone about this work, and then everyone in the world could access that, and then in the same way as coming to talk to me.
Exactly, that's fantastic. Yeah, that's exactly also the motivation why we do these podcasts, because like very few people outside Stanford would have the privilege to talk to you like with such a insightful conversation with your knowledge and brain. But by sharing this podcast, we hope that more people can learn from your wisdoms. And we're so grateful for you to join us today. Thank you so much. Is there anything that the community can help for you, or for your research, or for your company?
Thanks very much. Yeah, I think that our AI work fundamentally is an effort of of the entire scientific research community to contribute their know-how to the AI. So of course, I really hope more people to understand this mission and join us and check our website. By the way, path integral is a physics term. Our slogan is integrate all paths to knowledge. It's like quantum particles. You move all different paths and then you get a superposition of different paths. Yeah, so I really hope anyone who is interested in contributing our platform to contact us.
Awesome. Thank you so much. Really appreciate you coming to the podcast today, and looking forward to have more fun conversation in the future.
Thanks very much. Yeah,
Thank you.
It's really nice talking to you.
Thanks for watching the full interview. If you got value from this conversation, please drop a comment, and subscribe to Founder Coho. We've got more founder insights and deep dive interviews coming your way, so don't miss them. See you in the next one.